Good morning, my lovely tenors. Right, buddies, this is the next lesson that you've all been waiting for, my buddies. The lesson where you get to do tons of practice of quadratic sequences. Are you excited? Oh, good, I am as well. Okay, buddies, so, I know the topic that I taught you last time was proper tricky. You guys have done very, very well, though, based on the homework that I looked at that you guys had done. You do seem to have your head around it, but still, even though you do have your head around it, I don't think it would hurt for us to do a little bit more practice. And so that's what today's lesson is about, is just a little bit more practice. So my goal for you today is we're going to do 3 questions together. Once those questions are done, I'm going to set you off and you're going to have the entire period to just do as much practice as you possibly can so that you'll be absolutely, amazingly ace at this forevermore. Okay, so one more time, my buddies, here is how this stuff works. So if you check it out, you know in quadratic sequences that you always kind of end up with an expression that looks like this in the box on the right hand side. It's always something n squared plus something that is linear is what we call this in maths actually, but something with like an n and a constant at the end. That's always what it kind of looks like when you're all done. So the yellow bit, which is the n squared bit, and the blue bit, which is the other bit. They're just added together, my buddies. That's what this plus is about in the middle. If you can know what both of those two things are, you can add them up together. Okay, now I know you maybe remember this from last lesson, so here's what I'd suggest. I'm about to do question A. Now, if you're good at this, I would suggest right now, in a sec, and nearly now, put me on pause and just see how far you can get on your own. Because then you can either fast forward me or skip right until the right until you see what the answer is. And I'll draw a square around it so you'll be able to find it. And yeah, you can see if you can do it on your own without me. So I would suggest pushing pause, but if you want some help, because you don't quite remember, which is going to be loads of you, let's just do it together now. So you ready? People who are going to pause, pause. And everybody else, here we go. What you do again, my buddies, in order to find the quadratic thing is you need to find what's called the quadratic sequence, is you need to find what's called the second differences. Now, they're not too bad. All you've got to do is subtract the terms that follow one another. So in this one, you go 1 take away -1, and that makes 2, because that's the difference between them. 7 take 1 is 6, and 17 take 7 is 10. Now that, buddies, are called the first differences, okay? These are the first differences because we've taken them away once. That's why it's first. Cool. What we actually need, though, are these what are called the second differences. 6 take 2 is 4, and 10 take 6 is 4. And what you'll always spot is that the second differences are always the same when you're getting these quadratic ones. Now, do you remember what you do with that from last time? Well, if you said, yeah, it's linked to the yellow part, it's linked to the squared bit, you're right, because actually, here's what it means again. It's actually 2a, which equals the second difference, okay? So this, oh, I'm kind of running out of colors here a little bit, but that's all right. This 4 matches up with this 4, okay? It's the second differences, which is equal to 2a. Now, that was a rule last lesson. Here, I'll even show you it. That was a rule, remember? That was a rule? Boom! We proved that that's the case. So the second differences are always just equal to 2a. It's just something you kind of got to know now. You got to memorize. Okay, so if the second difference is if we have 2a equals 4, that means, my buddies, that a is equal to 2. And what does that mean? Well, if a is equal to 2, and you look up here in the yellow bit, that means it's linked to this one, okay? It's going to be linked to, and here it is. See how a was 2? That means 2n squared. What you've just worked out, that I've just colored yellow, is the same as this yellow up here in the box. So the yellow part's done. Now all we got to do is get the blue part. Now do you remember how that worked again, buddies? Yeah, that's right. We got to do that weird table stuff. So what do you write out? You write out the sequence again. So little spot for the sequence. It was -1, 1, 7, and 17. Now that's the whole sequence. The next thing you put is actually what the linked sequence is, which is the 2n squared, okay? It's the yellow one, so we're going to put the yellow one there. Cool? Now, if you put the yellow one there, it's 2n squared. Now, this term here, so you got to remember this too. This is the first term, the second term, the third term, the fourth term. So in order to get what 2n squared is, first step first is you take the n, which is the term that we are on, and you go 1 squared, which is 1, times it by 2 is 2. This one here, you go 2 squared, which is 4. Yeah, because we're doing the squared first. 4 times 2 is 8. 3 squared is 9, times 2 is 18. This one here, you're going to go 4 squared is 16, times 2 is 32. Now when that's done, here's what you're going to do. You're going to subtract them from one another, because what you're doing is you're taking away the yellow part. So if you think of this equation up here, if you take away the yellow part, you'll be left with the blue part, which is what we need to finish the question. So let's do it. Now this is going to be a bit tricky actually, but let's do it anyway. Okay. -1 minus 2 is actually -3, so you got to be really careful on your negatives there. 1 minus 8 is -7. 7 minus 18 is -11, I think, isn't it? Yeah. And then 17 doubled is 34, so this is going to be -15, I believe. Yes. Yep. So there we go. We got it. Cool. Now, believe it or not, this entire section here is the blue bit now, because you took your whole sequence, which is the whole box, you took away from it the yellow part, that leaves you with the blue part. So all you're going to do now, my buddies, is get the nth term that's linked to that. Okay, so look at what's left over. We just need to have its nth term. Well, if you look at what's left over, here's what we're going to get. It's counting down in 4s each time, it looks like. So it's going to be -4n. We're doing like the normal way now, the nth term. It's -4n because it's going down in 4s each time. And remember that trick that we had, that we can just sneak in the 0 term here? So it's actually going to be, if you add 4 to go this way, that's actually 1. It's -4n plus 1 is the nth term for the blue. Yeah? Happy days, buddies? And this is it. You've got your blue, you've got your yellow. So the total final answer, nth term, my buddies, is the two of them together. It's un equals 2n squared minus 4n plus 1, like an absolute boss. Okay, buddies? So, I hope you can see it. That's the yellow part, and that's the blue part. Cool? So what we did was we put it in exactly the same format as the box, and there we go. I said I wasn't going to do too much explanation and just go quick, but I've been banging on about the explanation. Sorry about that, but I hope you really get it now. And that's why it works, and that's what the answer is. Okay, leaving aside now why it works, just trying to go for it. And I'm going to have to contain myself and not explain why it works again. Okay, my people who have paused, okay, you're all back with me hopefully again now. And here's the thing. I want you to do this one all by yourself. Literally all of you pause it, okay? And have a go. So you ready? Pause. Okay, and you're back. So let's see how you got on. I'm going to do this one quick because I promised I would. Okay, so let's do it. First things first is the first difference is 13 to 17 is 4. 17 to 23 is 6. This better be 8, and it is. There you go. First differences. Second differences now. 4 to 6 is 2. 6 to 8 is 2. That means the second differences are 2. You guys remember that that means it's actually 2a that equals 2. It's always 2a, and it equals the second difference. That means a is 1, which means that the linked squared part is actually 1n squared. Or just, you know, it's the same as just n squared. So that's your yellow bit. Okay, that's the first part. Now, what did you have to do next? I bet you guys remembered because of the last one. You had to rewrite the sequence. So first step is rewrite the sequence. And it was 13, 17, 23, 31. And then you put your linked one after, okay? N squared, the linked one, because we want to get rid of the squared bit. Oh, stop explaining it. Oh my gosh, I can't stop myself. So n squared. Well, the first term is 13. 1 squared then, because it's 1. The first term is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. What do you do next? You're right if you said you subtract them to get rid of the squared bit. 13 take 1 is 12. This is going to be 13. This is going to be 14. This is going to be 15. Cool. Believe it or not, that's the blue part, because you took the yellow part away from the entire sequence. Cool. We need its nth term though too. It's counting on in 1s, 12, 13, 14, 15. It's going on in 1s, so it's like 1n, because it's linked to the 1 times table. And the number that goes at the end, I like to just grab the 0 term, so get 1 ahead of it which in this case would be 11. It's 1n plus 11, which is the same as, you know, n plus 11. Well, guess what, buddies? That's the nth term of the leftovers. So to get the final nth term, the final answer is this. It's the two together. It's n squared from the yellow plus n plus 11 like a boss. The two parts together. Cool? Hopefully that's okay. That was way quicker that time for me, so I hope that that's still okay. Okay, now for C, I am going to give you a hint, but then I'm going to stop helping, and I want you to do it as well. This one says, show that 308 is the 10th term in this sequence. Now, I don't want to go out to 10 terms. I know that there's 4 already, and I know that some of you will be keen to go out to 10 terms. But if you would really want to go out to 10 terms, I'm just going to switch this to be 100 so that you can't go all the way out to it. So I don't want you to go out to 10 terms and find it that way. Here's how you're going to do this, buddies. I want you first of all to get the nth term like you did here. So just like what's in that red box. Nth term first. And once you know what the nth term is, all you have to do is put 10 in for n, because that's how you get the 10th term. So you guys ready? I want you to do it all by yourselves. And ready? 3, 2, 1, pause, go. Okay, and you're back. Let's check and see how you got on. So, let's do it. Let's do it. See, they do become routine, don't they? 11 to 20 is 9. 20 to 35 is 15. 35 to 56, oh my god. 35, 45, 55 is 20, and then one more. So 21. 9, 15, 21. Second differences. We've got 6, and then we've got, I hope 6, 6. Brilliant. So they match up, means we've not made a mistake. Cool. It's always 2a that equals that, though. So 2a equals 6. That means a is 3. Now, that means, my buddies, that the linked term, the linked expression, the linked term is going to be 3n squared, because that's from the yellow part, okay? I'm even going to highlight it in yellow. I'm going to keep the colors throughout to help you. So that's it. 3n squared. Beautiful. So we're ready for the next step. What do you do next? That's right, rewrite the sequence. See, I told you I'm going quick now. 11, 20, 35, and 56 is the sequence. What goes under the sequence? Yeah, that's it, the linked term, because you want the linked term under it, because if you take it away, it's going to get rid of the squared bit, and you'll be left with just the linear, the arithmetic bit. Cool. So here you go, that's the first term. 1 squared is 1 times 3 is 3. Second term, 2 squared is 4 times 3 is 12. Third term, 3 squared is 9 times 3 is 27. And the last one, 4 squared is 16. 16 times 4 is 48. Cool. What do you do next? Yeah, subtract. That's it to get it. 11 take 3 is 11, 10, 9, 8. And this one here, 8. Oh gosh, this is a weird one. This one here, 8? 8. This one here, 8. They're all 8. Oh gosh, that's bizarre. Okay, so we've got a fun one actually coming out here. This in theory, you won't believe, well maybe you will believe me. This is supposed to be an easy one, buddies. But I think it's actually harder when they come out as 8. Okay. I'm going to cut to the chase and just tell you that the answer to this one is just going to be 8, but I'm going to leave a gap because I'm not just going to tell you. I can't do that. I can't do that, my lovelies. So the other part of this expression is 8. So the total answer is going to be 3n squared plus 8. Okay. Now, if you're like me, you wouldn't be happy with that because you'll be like, Mr. Wade just made up a new rule. But I haven't made up a new rule. I'll show you why. To turn from 8 into 8, what do you have to go up by? Well, nothing, right? So it's in the 0 times tables because it's not going up by anything. It's staying the same. So it's 0n. Yeah, just like in the last one, how it was like 1n. What would the one previous be, just like last time? Well, 8, because they're all 8. So it's 0n plus 8, which is just 8. And that's why it's 8. Cool? Another way to think about it is it doesn't matter what term you're on. The answer is always 8. That's why there's not an n in it. Cool. So happy days. Sorry, over-explaining, but there you go. And that means it. You're ready to go. Final answer. Un is just going to equal 3n squared from the yellow plus the 8 from the blue. And that's what we've got. That's our nth term. Now we're ready to answer the question, because the question was this. Show that 308 is the 10th term. Well, let's test it. All you got to do is test 10. So, I get a different color, let's get black. Okay, so here you go. Test n equals 10. Well, if you did that, here's what you get. You get u10 equals 3 times 10 squared plus 8. Now, 10 squared has to go first. 10 squared is 100 times 3 is 300. And then you copy the plus 8, which is 308. So, guess what, buddies? Confirmed. That's what we were supposed to get, which is brilliant, because that is 308. That's what it wanted us to show in the question. So there you go, my buddies. Bish bash bosh. I hope that you are feeling good at this. It's a very tricky topic. I'm very aware of that. But I hope that after this lesson it feels less tricky, and I hope that you're feeling more confident. That's what I'm hoping for. Cool. So here's what I'm going to get you to do for the whole rest of the lesson. I just made this worksheet for you by cutting and pasting from a couple of textbooks. I put this U to the end thing in there just to help you remember. And I want you to do as many as you possibly can, okay? So you might not be able to get them all done, but I want you to do as many as you possibly can. So here's some nice normal ones. This is like the ones we just did, these two blue ones. These ones with pictures are the same, just switch them into numbers, right? This is 1, 3, see what I mean? Like, just switch them into numbers and it's easy. 1, 3, 4, 5, 6, see what I mean? Switch them into numbers and it works. Question 4 is like really hard, nightmare hard, so I would leave it out unless you really want a challenge. And then these guys are just more practice. So all of it's kind of like for like in terms of difficulty, except for question 4 is an absolute nightmare, but I know that some of you would like to challenge yourself and see if you can figure it out. Cool beans? All right, my buddies, that is it. One more time from me. I think we've got one more lesson of sequences after this, but you've done really, really well so far. And that's it from me. Take a picture and upload it to show my homework when you get it all finished. And that's it. So see you next time. Bye, buddies!